Hi, this is Noson Yanofsky. We're doing theoretical computer science. We're up to section 2.2. We're doing the homework problems. Okay, doing the homework problems is lots of fun. As usual, the warning is do not use this to just watch the homeworks being done. Try to do it on your own. Okay, unfortunately, the first problem is probably the hardest problem, but we're going to do it like that. Okay, so we're up to section homework problem 2.7a. We want strings in AB, okay, words in AB such that the number of A's is more than the number of B's. Let me just tell you how to do it, okay? Well, you put onto your stack, you put on all the A's, okay? And every time you have a B, you pop off one. But there's something else could happen also. You could start off with a lot of B's. Okay, for example, this word, B, 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 A. This word is accepted because there are more A's than B's. Okay, and so what you do is you put on the B's, and every time you see an A, you pop it. Okay, and then when you see an A and there's nothing there, you put on an A again. Okay, the most important thing is at the end you should have an A, at least one A on your stack. Okay, okay. So there's a lot of non-determinism here, and that's something we can't avoid because this word is also in there. You're going to put on all your A's. Every time you see a B, you're going to cancel, okay, and you'll have an A left. Okay, so it's an interesting problem. I think it's the hardest problem there is from the homework, but so we'll start with that one. So if you're lost in the first one, you're going to be lost because of the non-determinism. That's fine, but the other 6 problems we're going to do are not so hard. All the problems we're doing is we're writing push-down automatons for context-free grammars. That's exactly what we're doing. Okay, so let's do this one. As usual, the first thing you do is put on a $sign on your stack. Okay, and that's what that is. Okay, and then this is where the complexity comes in. This is where the non-determinism comes in. Okay, here's something. Okay, if I see an A and there's nothing on the stack, and I don't read, put the A on the stack. If I see an A and there's a B on the stack, then pop off that B. You popped off the B and put nothing on the stack. Okay, so every time I see an A and there's a B on the stack, take it off. Again, there's this major war between the A's and the B's. They cancel each other out, and we like that. But at the end, we want the A's to win. Okay, more A's than B's. Okay, as opposed to that, if I see a B and I don't read anything, put the B on the stack. If I see a B and I see an A on the stack, erase the A. Okay, and when this is finished, I will have nothing to read. I'll have an A on my stack. If I don't have an A on the stack, then I'll end up here. If I have nothing to read and I have a B on my stack, bzzzt, no good. That means you have more B's than A's, or the same number, or an empty. Okay, then go here. Okay, now here I might have many A's on my stack, so I want to pop them off. Don't read anything, pop off my A's, don't push anything. Okay, and finally, don't read anything, there's nothing to read. By here you get to, there's nothing to read, pop off, just get to the diamond, and accept. Okay, so you got to do a complicated thing with these. Let's do a nasty case. A B B A B. Oops. B A B B. Okay, let's do this. Okay, I'm going to put an A. Oh, we're going to put a $sign on the stack. I'm going to put an A. We're going to put an A. The B's are going to pop the A's. Okay. then we're going to put an A, and then we're going to pop the A. Then we're going to put an A and an A, and then we're going to pop the A, pop the A. Okay, and this word is not accepted because there's 1, 2, 3, 4, 5 A's, and 1, 2, 3, 4, 5 B's. This word is not accepted. If I have another B, then I'd put the B on, and I still wouldn't be accepted. If I have another 2 A's, then I would pop this off and put on another A, and that way it would be accepted. Okay, so this was kind of painful. Okay, next. B. B looks complicated, but it's actually not complicated. Okay, so it's as follows. The complement of A to the n, B to the n. Since we started talking about pushdown automata, since we started talking about context-free grammars, we've been talking about A to the n, B to the n. Those things where the A's and the B's are the same. Okay? Now we want the complement of A to the n, B to the n. These are those things, okay, that are not in this thing. Okay. So there are 3 ways to be in the complement of A to the n, B to the n. One is more A's than B's. More A's than B's. 2, more B's than A's. Okay? Because this is when they're equal. So the complement is when they're not equal. But another thing is 3, when it's not of the form A to the m, B to the m. It's not a bunch of A's followed by a bunch of B's. Okay, now what does it mean that a word is not of the form a bunch of A's followed by a bunch of B's? Let's just look at an example. A, B, B, A, B, A, well, let's just do B, 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 B. Okay, this is not a bunch of A's followed by a bunch of B's. Why not? Well, here it's okay, 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 here it's not okay. This is what it makes it not in that form. As long as you have a B and then an A, that means if this is in the complement of A to the n, B to the n, because there's a B in the A. As long as you have a B and then an A, it's no good. Okay, I don't care what happens afterwards. Okay, so there is a BA as a substring. Okay, so we have to do, we want the complement of A to the n, B to the n, we have to do, it's either in here, more A's than B's, or in here, more B's than A's, or in here, there's a BA as a substring. Okay, because the minute there's a BA and the substring, that means it's not of that form. Okay, good. Okay, so the big word is or. This or this or this. Okay, and we can do this in non-deterministic way as follows. First put down a $. Okay, and then there are 3 possibilities, because there are 3 possibilities to be in the complement. Okay, so the first possibility is as follows. There are more A's than B's. Okay, I'm going to do that as follows. I read an A. I don't pop anything. I don't push anything. Read a bunch of A's. In other words, a typical word here is A, B, B, B. Okay? So this has the same number of A's and B's, except these 2 are extra. So let's push those 2 on. Okay? And then do an epsilon move. Again, there's highly non-determinism in here. Do an epsilon move, and over here, now, so these two A's just pass by, and now every time there's an A, I want to push it on, and every time there's a B, I want to push it on. So if there's more A's than B's, that means I start off with something more than that, and then there's going to be the same amount. So it's going to be as follows. Every time I see an A, don't push any, don't pop anything, just push on an X. Let's say X. Doesn't mean you can push on an A, you can push on anything. I need to count and make sure that there are more A's than B's. The main point is this is wrong. Okay, because I need at least one. So I want A, comma, epsilon, epsilon. Then I need as many as I want. A, epsilon, epsilon. Okay, and finally, now I want an epsilon move. And over here, every time I see an A, push on an X. Okay. Great. Then, when I'm finished that, do another epsilon move. Go here. And this, we do the opposite. Every time I see a B, I want to pop off an X. So we do it as follows. If I read a B and I have an X on top of it, don't push anything on. Okay. Now, after this happens, then I'm going to have nothing to read, a $sign, and don't push anything, and accept. So this is the first part of the complement of A to the n, B to the n, where there are more A's. So let's just go through what we did before. These are all epsilon moves. Okay. So we don't know what is it, more A's than B's, more B's than A's, or the BA. Okay, so we have to try all three of them. Okay, well, let's go through this again. Go here, have at least one A that's just red, at least one A. Then we could have more than one A, then have an epsilon move, then we could have at least one X. Now then, every time I have an A, I push on an X. Every time I see a B and I have an X on top, I pop it. So this is just A to the n, B to the n, right here. It's just A to the n, B to the n. But we started off with more A's, and then we close that off. Okay? Now, there's another possibility. What's the other possibility? The other possibility is, I'm going to write it here and then I'll erase it. You have A, B, 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 B. Okay? So here, you're going to push on the A's, or you're going to push on X's. You're going to pop them off, and then I want to have a few more B's. At least one more B. Okay, so let's do that. So we're here. Every time we see an A, we don't pop anything, but we push on an X. Then you can do an epsilon move. And this says what? Every time I see a B and I pop an X, don't push anything. Okay, so this itself right here is A to the n, B to the n. But now we want something new. Okay, what do we want new? I next read a $sign. Okay, I finish pushing, I finish popping, I read a $sign. 1 second, we're not finished. And here, read more B's. How many more B's? As many as I want, but at least one. If I made this a regular epsilon move, that wouldn't be good. At least one more B. Okay, so this top one is more A's than B's, this next one is more B's than A's, and this one is going to have that somewhere along the line I have a BA. Okay, and so what I do is as follows. I don't care how many A's. Read all the A's you want. I don't care how many B's you are. Okay, now comes the non-determinism. Because when there's a B, I also want to do the following. Notice here, this question of whether or not there's a BA in your string has nothing to do with push-down automatons. That's a regular language. So I don't have to worry about the stack. Nothing said about popping or pushing here. Okay. What I'm doing now is if you go along and you see a B, could be it's a regular B, you don't have to do anything, but it could be it's the beginning of BA. The minute you see a BA, that means it's in the complement of this thing. And once you're here, I don't care what you see afterwards, A or B, once you see a BA, stay in the accepting state. That's the complement of A to the N, B to the N. Okay, good. Next. Okay, let's do it. One of the benefits of you watching this on YouTube is that you can pause whenever you want. Okay, good. Next. Okay, next is hard to understand what they want, but you'll see. The C and the D are made for each other. In other words, you want it. So let's just read it. It's W number X such that W reverse, the word reverse, is a substring of X for W comma X is a member of 0 comma 1 star. Okay, so you have word and followed by another word. Okay, but this word reverse is a substring of X. Let me just show you what it looks like. Okay, so something like this: 0, 1, 1, 1, 0, 0. That's going to be your W. Then you're going to have a number sign. Okay, and then you're going to have a lot of stuff. I don't know, 0, 1, 1, I don't care. And then you're going to have 0, 0, 1, 1, 1, 0, and then a lot of junk. Okay, this whole thing is X. Let's do this here. This whole thing is W. Okay, and this whole thing is X. But the main point is W reverse is a substring of X. This matches up to that. Reverse. Okay? Okay, great. Okay, we did a context-free grammar like this, but now we have to do a push-down automaton like this. Okay, very nice. How do we do it? Well, the way to do it is to think of this as a palindrome. It is a palindrome. Look, 0, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 0. Okay, it's a palindrome. But it's got stuff in between, and it's got stuff or junk at the end. Okay? Okay? So we have to do it that way. Okay, we have to think of it as a palindrome and do that. Okay, so let's think about a push-down automaton. How do you do a push-down automaton? How do you do a palindrome as a push-down automaton? Well, you push in 0, 1, 1, 1, 0, 0. Okay, when you see the dollar sign, you know you have other things to do. Okay, but once you get here, and you're going to get there non-deterministically, this 0 is going to pop off this 0, this 0 is going to pop off this 0, this 1 is going to pop off this 1, this 1 is going to pop off this 1, this 1 is going to pop off this 1, this 0 is going to pop off that. Okay, so this you push, then you wait till you get here, and then you pop. Okay, good. So that's the idea. Let's actually do it. Okay. Okay. Hold on, don't move. Okay, I don't think it's AB. I don't think it's 0, 1. I think it's AB. But I just want to make sure. No, 0, 1. Okay. Okay, great. Okay, so here's what we do. Every time I see a 0, I want to push it in. Every time I see a 1, I want to push it in. So if I see a 0, don't pop anything. We're doing zeros. Push on the 0. If I see a 1, don't pop anything. Push on a 1. That's it. Okay? Whatever order it comes. Then, if I see a number sign, that means, okay, we're going to the other place. We're going to the next thing. Okay, again, don't pop anything because we read here. Okay, and don't push anything. Very good. Now, what do I want to do? Okay, now, what do I want to do? Now, I want to read this junk. In other words, I don't care what's there, so I want to read it. I want to think of it as junk and I want to read it. Okay, and so it goes as follows. 0, comma, epsilon, don't pop anything. Don't push anything. 1, comma, epsilon, don't pop anything, don't push anything. Just do that junk. Okay, great. When you're finished, and I don't know when you'll finish, so we have to do this non-deterministically. Okay, so you go here, and now, what do I want? I want to pop off what I pushed on. Okay, and here's how I pop off when I'm pushed on. I see a 0. I pop off a 0. I don't push anything on. I see a 1. I pop off a 1. I don't push anything on. Okay, that gives me this. That gives me the exact opposite of this. Now, everything that's pushed in, I pop out. Great. Next. I just want to go to the next part. The next part is you see more junk, more things. I don't care what it is, but we're going to do it. Let's get rid of it. Now, I'm going to do the exact same thing here. I see a 0. I don't pop anything because I'm finished popping everything. I see a 1. I don't pop anything. Cut that. Next. Okay. The next is I'm now finishing reading everything, and now I have nothing to read, a dollar sign, nothing to push except. Okay, I'd like to help you read this. This is the beginning of palindrome. This is the end, or second half of palindrome. Okay, this is junk, and this is junk. And that's that's exactly what you have. You have the beginning of the palindrome, a number sign, junk, end of palindrome, junk, finish. Okay, great. Okie doke. Okay, let's erase. Now, 2.7D is a lot like this. Okay, it's basically x1, number sign, x2, number sign, xi, number sign, xj, number sign, xn. You've got a bunch of strings. Okay, xi is a member of 0, 1, star. All of them, let's xt. All of them are made of zeros and ones. Okay, but we have the following: xi equals xj reverse for sum I and j. In other words, somewhere inside there is two of them, here, these two, such that they're reverse of each other. Let me give you an example. You're going to have a lot of stuff here. Number sign, da, 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 da. At some point, you're going to have something like this. 0, 1, 1, 1, 0, 0. Use the same stupid thing, it doesn't matter. Okay, number sign here, dot, dot, dot. It's going to be a lot of junk over here, Okay, and then you're going to have 0, 0, 1, 1, 1, 0, number sign, and then junk over here. So let's just see what we're going to have. Basically, this is going to be a lot of junk. This is going to be a lot of junk. And this is going to be a lot of junk. But the main point is this and this are reverse of each other. Okay, how do you do this? Well, it's the same exact idea. This is basically a palindrome. This and this is a palindrome. 0, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 0. Just reading it backwards. Okay, it's a palindrome. It just has junk before it, junk in between it, and junk at the end. Okay, and so we're going to use the same thing. How do we do this? We read the junk, we push on the beginning of the palindrome, we read more junk, we pop off the end of the palindrome. And that's it. Okay, so let's do this. I'm going to erase. I need all the room I can get. It's not hard. Once you see this, it's exactly the same thing as before. Okay, so it goes as follows. Push on a $sign so you can have the bottom of your stack. Then here, push on number sign. It's part of a junk. Epsilon, epsilon, 0, epsilon, epsilon, 1, epsilon, epsilon. I'm sorry, I said push on. No, just read past. This is junk. Read past the junk. Okay, great. At some point, you're going to go to the next stage. What's the next stage? Okay. The next stage says, if I have a 0, don't pop, push in the 0. If I have a 1, don't pop, push in the 1. Okay? This is xi. Okay? This is xi. Great. Then, you're going to read a number sign and continue on. Okay? What do you do now? Now is more junk. Okay, so we're going to have to do this. Again, we know what to do with junk. Okay, basically, number sign, epsilon, epsilon, 0, epsilon, epsilon, 1, epsilon, epsilon. Okay, so that's a lot of junk. Okay, at some point you're going to be finished the junk. So let's put a number sign here, epsilon, epsilon. And now you're going to have the reverse. So I wrote this as xi reverse. Okay, and what are you going to do? Well, you pushed on xi, so you want to pop it off. So here's the way it does. If I read if I read a 0 and I pop a 0, go on. If I read a 1 and I pop a 1, don't push anything on. Okay, and that's it. Next, this should probably be a number sign. In other words, that's what's separating us. Okay, next, you see a number sign. Don't read anything, don't pop anything, don't push anything, go here. Okay, now what? More junk. Well, we know how to do junk. Number sign, epsilon, epsilon. 0, epsilon, epsilon. 1, epsilon, epsilon. Okay, and when you finish the junk, what do? Don't read anything, there's nothing left to read. Pop off the dollar sign, don't push anything on, and doubly accept. This is also junk. So now we have junk, followed by xi, followed by junk, followed by xi reverse, followed by junk. Which is exactly the picture I drew before. So that's very nice. Okay, great. That's 2.7. Okay, 2.10. Okay, nice. .10, which basically says a to the I, b to the j, c to the k, where I equals j or j equals k. Keyword, or. What does or mean? Branch out into two possibilities. That's what you want to do. You want to branch out into two possibilities. Okay? So one possibility is I is equal to j, one possibility is j is equal to k. The main point, the reason why we're doing this is because we saw that a to the n, b to the n, c to the n is not doable by a pushdown automaton. In other words, if we want all three to be equal, it's not doable. But what is doable is these two could be equal, and what else? These two could be equal. Okay, we can't do all three to be equal, but we can do two of them. Okay, and what we're going to do is as follows. If these two are equal, then we know how to do this. We push in all the a's, we pop out for every a, for every b, we pop out an a, and then we just read the c's. I don't care about the c's because they're not equal. Or another possibility is just read the a's, then push in the b's, and then make sure that for every b there's a c. Okay, so we're going to do that. Not hard. Okay, we start here. I'm going to make this into two things. Push on a dollar sign. Push on a dollar sign. Okay, and let's say I is equal to j over here. So what do? Every time we see an A, we push it on. A, don't pop anything, push on an A. That's it. Then, if we see a B and we pop off an A, don't push anything else on. Come here. Okay. Now what are we going to do? Every time we see a B and we pop an A, these two are equal. We're okay. Don't push anything. Okay. So for every B that you read, there'll be an A in the stack. Great. Then what? Well, at some point you're going to read a C. Okay. And here, I'm finished with my stack. Don't touch anything with your stack. I'm finished. But I still have a lot of C's at the end, so read the C's. Okay? When you're finished reading the C's, nothing to read anymore. Pop out the $. Nothing to push anymore, except. Okay, that's one possibility. Again, push on the A's, pop off for every B, pop them off. Just read the C's. Now we're going to do the other way. Here we have J is equal to K. So just going to read the A's, push on the B's, pop off with the C's. Okay, so let's do it. Just read the A's. A, comma, don't pop anything, don't push anything. Okay, great. Now, when I see a B, I want to, don't pop anything, but I want to push on the B's, just like over here I pushed on the A's. Okay, great. Oh, I need something here. What should we do? How about this? B, comma, E to B. Okay, next. I could have made this into an epsilon move. Okay, next. Great. Then, when I see a C, I'm going to pop off that B. Okay. When I see a C, and I pop off a B, that's good. Okay, and finally, so we just read the A's, we pushed on the B's, for every C that we read, we pop off a C, and then pop off the $. You're at the end of your stack. Do it. That takes care of that. Okay, nice. Okay, now, another one of the problems that we gave I gave it, it was not in the book, okay? And I want to do it in two different ways because there's two ways of thinking about it, and both of them are legitimate. So how about this? A to the n, we don't need that. A to the n, B to the 2n. Okay? Twice as many B's as A's. Okay? And there are two ways of doing this. One is, look, okay, how do we do this? A to the n, B to the n. I push on the A's, and every time I see a B, I pop it. Great. So how do we do A to the n, B to the 2n? Well, instead of pushing on one A, push on two A's. It's simple. So every time I see an A, push on two A's. That's it. Okay? Then, at some point, I'm going to see a B. Okay? I'm going to pop an A, don't push anything else. Then every time I see a B, I pop an A, don't push anything else. And then at the end, I pop the $, and I accept. The main trick is right over here. Every time you see an A, you push on two A's. Okay, that works. Okay, but there's another way of doing it, and it's very nice. So let's do the other way. What's the other way? The other way is as follows. Push on one A, okay, and then instead of popping off for every A, so let's do this, A, B, 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 B. 6 B's, okay? So every time I put on an A, that's good. Put on an A, that's good. Put on an A, that's good. I'm going to have 3 A's on my stack. A. And then I pop off with the B's, but I need 2 B's to pop off every A. So BB, that pops that off. BB, that pops that off. BB, that pops that off. Okay, that's another way of doing it. Let's show you how to do that. Okay, and by the way, both ways are legitimate. Okay, so this is what we're going to do. Every time we see an A, don't read anything, just push on an A. That was pretty simple. We did that before. Okay? Now, I want to make this an epsilon move. Okay. Now, here's the trick. I need to see 2 B's before I pop off any of them. Okay? So, I need to read a B. Don't read anything. Don't push anything. Come here. Damn, damn, damn. Okay. Then read 1B, then read and pop an A, like that. And you go around and around. 1, 2, 1, 2, 1, 2. At some point, I'm going to be finished, so I'm not going to have anything more to read. A $sign, and then there, and we get that. Okay, it has to come from here because I have to do 2. Because this is not acceptable. This is 1, 2, 3, 1, 2, 3, 4, 5. This is not acceptable. Or this is not acceptable. This has 7. 1, 2, 1, 2, 1, 2, 1. I want it to die if I'm over here. I want it to go from here. Okay, that takes care of that. One more last problem. Not hard at all. Okay, I think it's okay. It's A to the, I think the book does this. B to the J. C to the I plus J. Okay, and the way we do this is basically we push on an A. We push on, for every A we push on an X. For every B we push on an X. Every time we see a C we pop it off. Okay, let's just do this. Every time I see an A, I push on an X. Every time I see a B, I push down an X. Every time I see a B, I push down an F. Every time I see a C, and I can pop off an X, I pop it, and now we do the same thing. Every time I see a C, and I can pop off an X, I pop it. Okay, and finally, that's it. Okay. So those are nice problems, and that was 1, 2, 3, 4. We did 4, 5, and then we did 5 examples from the book, and then we did 2 more examples, 2 ways of doing one thing here, and there's a third. So we did 8 push-down automatons all together. Anyways, push-down automatons are nice things. You have to just think about what would you do if you had a stack, okay, and work out the problem like that. Okay, thank you.